take the idea of foiling, of multiplying binomials, and realize that there are a couple of what I like to call special cases. So let's take a look. I'm going to start by showing you this slide. And I'm going to ask you to stop the video and FOIL row 1, and then FOIL row 2, and FOIL row 3. So multiply the binomial times the binomial and fill in sort of this chart. You can just do it on paper. And then I want you to look at row 1. Is there a pattern? Look at row 2. Is there a pattern? Row 3, are you starting sort of to see something that's going on? So pause the video, do the foiling, see if you can kind of notice a pattern, and we'll come back together in a minute. Okay, guys, so let's take a look. I'm going to go on to the next page, which is going to give you the answers. So when you FOILed x plus 8 times x plus 8, you would have multiplied x times x for the f for the first and gotten x squared. The o would have been 8x, and the I would have been 8x. So you would have had two 8x's, which is 16x, and then 8 times 8 is 64. You would have had y squared, 5y on the outer, 5y on the inner. So 2 times 5y, or 10y. And then 25 on the end. 2p times 2p is 4p squared. You're going to have 6p on the outer and another 6p on the inner. 2 times 6p is 12p, and 3 times 3 is 9. When we come down to the next one, d squared, you've got a minus 6d and a minus 6d. So 2 times negative 6d would be 2 times negative 3d would be minus 6d, and a negative times a negative, negative 3 squared would be positive 9. T squared, we have minus 1t on the outer, minus 1t on the inner. So 2 times minus 1t would be minus 2t, and a negative 1 times a negative 1 is a positive 1. 9r squared is 81r squared. We have negative 18r and negative 18r. 2 times negative 18r is negative 36r, and a negative times a negative give us a positive 4. Now when we come down here, we have x times x giving us x squared. The outer is negative 4x. The inner is positive 4x, and that term drops out. And 4 times negative 4 is negative 16. On the next one, k times k is k squared, a negative 9k on the outer, a positive 9k on the inner, makes 0k, it drops out, and we end up with 9 times negative 9 is negative 81. And then 9c squared with a negative 21c, a positive 21c adds to drop out, and then 7 times negative 7 is negative 49. So let's go back to row 1, and you're going to notice that everybody in row 1 are what I call identical twins. And if you look at row 2, same thing, they're identical twins. And notice that when we multiply identical twins, we end up with a quadratic trinomial, 3 terms. We have the x squared on the front, we have the number, the constant squared on the back, and the middle term is if you just take those inner 8x and double it. So y squared, 25, 5x doubled. 2p squared is 4p squared, 3 squared is 9, and the middle term will be 6p doubled. Now when you put the minus in there, you still get that d squared on the front. You're still going to get the positive on the back, just like you did up here, because a negative times a negative is a positive. And notice that a negative 3d doubled gives you the negative 6d. So the only difference here is that we end up with a minus in the middle because each of the o and the I are giving you a negative 3d, and we double it. So what we're noticing is if we have identical twins, we square what is out in front, we square what is the last, and the middle term, what I like to call the OI, the OI, is one of those multiplied and doubled. So if you take the I, the inner, negative 1t, and double it. Now let's go on to this other case down here that they're no longer identical twins. They're twins off by a sign. Fraternal twins, let's call them. This time, we end up with the middle term dropping out each time because the positive and the negative, the O that's positive, the I that's negative, or vice versa, makes the middle term drop out, and we end up with a quadratic binomial. Most of the time, when we multiply two binomials, we get a quadratic trinomial. But the one case that doesn't happen is this one, where we have the twins but off by a sign. We end up with a quadratic binomial. Now you might be saying, Mrs. Woodruff, I don't care about these special cases. I can just FOIL and get the answer. And you would be right. However, we need to start recognizing these, because what we're doing in the future is to go backwards. And if you can recognize that this is a special case, okay, that you can recognize that, this one is a special case, it will help you do what's called factoring later on. Right, so what I want you to do right now is to go up, and without foiling, just kind of using this idea, can you predict what this answer would be? Do you know what the first term is? Do you know what the last term is? And can you figure the middle term out by just looking right here? Okay, so let's see how you did. The first one should be 9v squared. That's the 3v times itself. The end term would be the 7 squared. And then the middle term would be 7 times 3v doubled. The next one, the v squared, the negative 5 squared, and the middle term would be negative 5v doubled. When we have the fraternal twins off by a sign, then we're just going to square the first term and square the end, and it will always be a subtraction. All right, so let's put this all together. There are two called the square of a binomial, and down here we're going to be talking about the difference of two squares. So basically, when you're taking the identical twins, it would be 5x plus 3 times itself. You could actually write that this way, right here, instead of writing both binomials. So you're going to take that first term and square it. You're going to take that last term and square it to get the 9 at the end. And then you take these two times each other, 15x, and double it. And you end up with 30x in the center. So 25x squared, there's the 9, and 5x times 3 is 15x doubled. This is kind of telling you how to do that in general. And here's another one. I'm going to take the 4x and square it and put it in the front. The negative 1, square it and put it at the end. And then I'm going to take 4x times negative 1 and double it. And that gives me a negative 8x in the center. Okay, the difference of two squares is a little bit simpler because we know the middle term, the oi, is going to drop out, the o and the I. So you're just going to square the x, get an x squared, square that 6, get a 36, and there will be a subtraction. It's called the difference of two squares. See how you end up with the difference of two squares. Okay, so I'm going to give you a second to try these and see if you can do them without foiling. Can you just go down and see that they're all special cases? They're either identical twins, like this one, or they're the difference of two squares. They're fraternal twins. If they're off by a sign, the oi is going to drop out. And if they're identical, you're going to have a middle term, and you can get that by doubling the o or the I. Pause the video and see how you do. Okay, the first one is a difference of two squares here. Okay, we're going to end up with. So you're going to square the d and square the 11, and there's a minus in between. That's the easy one. Next one, again, fraternal twins. They're identical but off by a sign. So you're going to square c squared times c squared is 6 to the 4th. 8 times 8 is 64. There's a minus in between. We're actually going to skip this one. Let's just stay with the same idea. Notice this is the same again. So we're going to square the 2, which would be 4. We're going to square the 7v, which would be 49v squared, and then there's a minus in between. Notice that this one is not written in standard form. If we were going to write that in standard form, we would put the negative 49v squared in front of the plus 4. Any more? Yep, down here. They are identical but off by a sign. So 9p squared times itself would give me 81p to the fourth, and that would be my first term. 5q times 5q would give me 25q squared. And because they're off by a sign, there won't be an OI, there won't be a middle term. And these are called the difference of two squares. The difference, and you've got two things being squared. All right, let's go back and realize that these two are not that case because they're identical twins. So this is the case where I'm going to take the 3y, square it to get the 9y squared. I'm going to take the negative 7 times negative 7, and that's going to give me a 49. We're going to see that in a second. And then all I have to do is multiply these two together, negative 21y, and double it, and that'll give me the center. So there's the 9y squared, the 3y times itself. There's the positive 49, that's the negative 7 times itself. And then when I multiply these two, I get negative 21y, and I double it. 2y squared would give me 2u squared would give me 4u squared. 9v squared would give me 81v squared. But because it's an identical twin, there is going to be a middle term. 2u times 9v is 18uv, and there's going to be two of them, one for the O, outer, and one for the inner I. So I'm going to take that 18uv and double it for the center. 2 times 18 is 36. Okay, so let's just take one more minute to just show you, just ones that are a little more complicated with some, different variables. But I often use this idea if I don't have a calculator and I'm trying to square a number like 93 squared. I write this as a sum or a difference and see if I can use the ideas that we've just been talking about. So 93 is 90 plus 3. So if I take 90 plus 3 times itself, right, this would be the identical twins. So I'm going to square the number out in front without a calculator. I can take 90 times 90 and realize that I'm looking at 8,100. I can take the 3 times the 3 and realize there's going to be a 9. And then I can multiply these two times each other. 3 times 9 is 27, so 3 times 90 would be 270, and double it. So it would be the 8,100 plus the 549, and 8,100 plus 549 would give me 8,649, and I never touched a calculator. Now down here, the 63 could be 60 plus 3. The 57 could be 60 minus 3. This is the off by a sign, so the middle term is going to fall out. This one's really easy because 60 times 60, well, 6 times 6 is 36. I need the two zeros, so 3,600. And 3 times 3 is 9, so it's 3,600 minus 9, which is going to be 3,591. And I never picked up a calculator. So it's just something that you can see. There's a gentleman named Art Benjamin that does math magic, and hopefully we'll get to see that video at some time. But he does a lot of squaring of numbers in his head, and he's using some of these ideas. All right, let's get back to throwing some variables in here. So this is the identical twins, so there is going to be a middle term. I'm going to take 3x squared and square it, which is going to give me 9x to the fourth. Is everybody with me? Oops, sorry. Then I'm going to take out in the end, I like to go right out and realize I'm going to have 25y to the sixth. There will be a middle term, and I multiply these two, and I get 15x squared y to the third, but there's going to be two of them, so there's going to be 30 of them, and there is that one. How about if you try this last one? Stop the video and see if you can figure this one out on your own. Alrighty, we're going to have a difference here, so there's no middle term because it's going to fall out. It's the difference of two squares. Answer you'll see in a minute. 9a to the fifth times 9a to the fifth. We're going to square that and get 81a to the 10th, because when we multiply, remember, we add the exponents. And then I'm going to square the guy out in the back. 2 squared is 4, and b to the 3rd squared would be to the 6th, and there'll be a subtraction in between. No middle term, because you've got 1, the outer is positive, and 1, the inner is negative, and they basically cancel each other out.